Welcome to this Engerati webinar. My name is Rose Bundock, Head of Commercial Content here at Engerati, and I'll be your host for this live session. Before we begin this webinar on microgrid islanding, I'd like to go through a couple of housekeeping items. Firstly, this presentation is available to download as a PDF file and also as an MP3 audio file for easy access. The webinar is also available on demand on Engerati, so you can share the key learnings with your colleagues. In this webinar, we'll be discussing microgrid islanding. How does it work and can it benefit you? To unpack the topic of resilient microgrids, we're joined by two representatives of French manufacturer of power and energy performance solutions, Socomec, Giovanni Di Caro and Elodie Heston. And to give us a view from the utility side, we're joined by Etienne Radvani from EDF. I'd now like to hand over to Giovanni, who will introduce the speakers in more detail. We look forward to hearing your presentations.
Okay, welcome everybody, and thank you for attending to this Socomec webinar. And now let's go through the introduction of each animator. So I'm Giovanni Di Caro. I've been working as Energy Storage Solution Director since 2016, and previously I was in charge of the innovation project for the Socomec group, where I started to work actively on energy storage application and demonstrator from 2011. Now I give the hand to Etienne Radvani to make his own introduction.
Hello everybody. So as Giovanni said, I'm Etienne Radvani. I work for EDF, for EDF direction called Système Énergétique Insulaire, or SEI, which is the EDF direction in charge of the electrical system in the French islands that are not connected to the mainland. So my topic of work is the energy transition on those islands or areas of these islands that are considered as microgrids, so with typical power of less than 10 megawatts. So we are talking about some of the Brittany Islands, such as Île-de-Saint, that we're going to talk about today. We are talking about Miquelon, or some areas in French Guyana, which are located inside the Amazonian forest. So these are examples of microgrids that I'm working on. And for my background, I used to work a couple of months ago for the research and development direction of EDF on topics related to stationary storage.
And finally, I'm Elodie Heston, and I'm Energy Storage Solution Marketing Manager at Socomec. I've been working in this position since beginning of last year, 2017. And before, I was working for Socomec as a marketing manager for changeover switches, so not exactly the same field. And now I will give hand again to Giovanni to present the agenda.
Okay, let's have a quick view on the agenda. So first part of the agenda, I'm going to present you the Socomec company, then some element about renewable and storage drivers and services. To continue, we will continue with the Socomec Energy Storage Solution offer presentation to give you further detail about what is the perimeter of the offer, and then the main topics of this presentation with the SEIN Island project. Socomec presentation. So, Socomec is a French independent family group acting as an equipment manufacturer for electrical solutions targeting performance, quality, reliability, and efficiency of the power and energy for low voltage application. Socomec has been founded in 1922 and today account about 3,200 salaries all around the world, distributed on 9 sites of production and 27 subsidiaries. In 2016, Socomec turnover was about 480 million euros, down through 30,000 customers and 18,000 project reference. Socomec developed its activities on 4 areas of expertise. The historical one is based on electrical switches technology for disconnection, protection, and transfers. The second activity is dedicated for power conversion, including UPS, PV inverter, and energy storage solution. The third activity is focused on energy efficiency with a full package starting from the electrical sensor, the power monitoring device, up to the software suites. And the last activities support the 3 other one with all the services like audit, corrective and predictive maintenance contracts, spare parts management, training, and the end-of-life management of the different equipment that we can provide. Now, let's go through the renewable energy and energy storage driver and services presented by Elodie.
Thank you, Giovanni. So, as Giovanni just said, I'd like to share with you the reasons that led Socomec to consider energy storage applications. And therefore, let's have a look at some of the drivers for renewable energies. In the last years and months, it has been made clear that there is a real favorable context worldwide for renewable energies. So several reasons can explain this. To begin with, we have the worldwide demand increase for energy. So we see that everybody, everywhere, needs to have high-quality electricity access. Then we have a real need for control of the energy costs, which leads to an increase of the energy efficiency needs. There is also a green attitude trend. So behaviors are really moving, and people tend to reduce the greenhouse gas emissions. And finally, the impact of new technologies developments, such as electrical vehicles, IT, make it necessary to have high quality and availability energy. So all of this is there to boost storage development in order to allow massive integration of this energy, of these renewable energies, and also to limit their constraints due to their intermittency. Concerning the storage, energy storage systems bring lots of advantages. So first of all, flexibility. So they can provide this by ensuring demand-response balance in order to support the grid. They can also provide flexibility by managing the production and the consumption peaks, so by doing peak shaving, smoothing, and shifting, and also by synchronizing the consumer uses with the renewable productions. Another advantage is the efficiency. So thanks to the maximization of the local renewable consumption, the reduce of the costs, so with the management of the peaks and the management of the tariffs, the energy storage systems enable to reduce the bill. And finally, another point is to defer or to avoid the grid investment that could take place. Next, we can have some stability of the grid by allowing massive integration of renewable energies without any grid constraints, by providing primary and secondary reserves, and by supporting the grid voltage regulation. And finally, energy storage systems bring availability. So for example, for untied grids, it's really a way to electrify the microgrid, and it's also a way to bring resilience in case of grid failures. So let's move on to Socomec energy storage offer. Socomec has a long experience on the field with its UPSs that include battery management and power conversion management that Socomec has been developing for 45 years. Linked to this experience, it has been logic to start developing the PV inverters, which are unidirectional converters working as a current generator. Then in 2013, Socomec launched its on-grid energy storage systems, which are bidirectional power converters acting as current generators only and only working as grid tied. And finally, in 2014, we launched our on and off grid energy storage systems, which can work as current generator when it is grid tied and as voltage generator when it is disconnected from the grid. In the frameworks of Nice Grid project, which was a French demonstration project, and after NEDIS and EDF R&D qualification, our system did, for the first time in Europe, the islanding of an industrial district during 12 hours without any rotary machines, like, for example, DG. On Socomec side, we are targeting 4 main applications for storage. So 2 of them are in front of the meter. Firstly, hybrid microgrids to ensure high quality energy. And secondly, smart grids or electrical vehicle charger support, where the main goal is really to eradicate grid congestion. We are also targeting 2 behind-the-meter applications, which are commercial and industrial smart buildings, where the energy storage system aims at managing the peaks, at operating the energy arbitrage, and maximizing the self-consumption. And the last is the renewable energy production management in order to do the profiling of the energy production. I can't change the slide, sorry. Okay, it works. So, I did one too much. Okay. Okay, so concerning Socomec's offer, we are offering a turnkey solution with batteries that can be lithium-ion or lead acid, with DC and AC distribution cabinets, paralleling cabinets in order to parallel all the sources that can be PV, wind, grid, gensets, hydro, whatever the application has. We offer also the SUNSYS Park, which are the PV inverters, the SUNSYS PCS Square, that are our bidirectional power converters that can be on-grid only or on and off-grid, so with the islanding mode option, and the PMS control cabinet. This cabinet has the intelligence to do a real-time management of the microgrid, really focused on the electricity availability. In case of an application requesting an EMS, for example, to forecast the use of the sources in order to have a fine-tuning of the application, we can work with some partners to provide the EMS. In our partners, we have, for example, EDF Store and Forecast, which was the one that we used for the Saint Island project that we are going to talk about just after. Concerning our PCS products, the main features of the products are that we have 33, 66, 100, and 200 kVA per conversion unit. These units can be put in parallel in order to reach several megawatts applications. And they are modular. They are composed of 1, 2, 3, or 6 modules of 33 kVA. And the architectures can also be modular with one transformer per unit, for example, or one single transformer for all the units in parallel. This gives more flexibility to the installation. It also increases the efficiency, the maintainability, and the scalability. All of this makes it possible to use our products for low voltage, but also for medium voltage grids. To sum up all of what I just said, what is important to keep in mind is that our machines are available from 33 to 200 kVA to answer to on-grid applications, but also to on- and off-grid applications in case of the PCS2 IM version. In this latter version, we introduced some key features, such as the black start functionality that enables to power an untied microgrid. We also introduced some boosted overload and short circuit features, preventing to oversize the installation. The products also have full circular 4 quadrants PQ capabilities, and the PQ response time are lower than 50 milliseconds. Finally, this year, we launched the SUNSYS Extend range, which is a fully scalable solution bringing an answer both for on-grid and for islanding applications. And this solution is available from 33 kVA to 800 kVA with an autonomy from 1 hour up to 4 hours. Let's move on with Île-de-Sein project.
Okay, now in order to have a concrete vision of what, in which way this kind of offer and product can be used, now let's have the presentation of the SEIN Island. The SEIN Island project has been led by EDF SEI. This project is located on the French west coast close to Britain. The application is a smart isolated microgrid for renewable deployment, greenhouse gas reduction, and grid resilience demonstration. In this application, the energy storage solution allows massive PV energy integration, multiple sources management like diesel generator, PV production, energy storage solution. Also, a high quality and stability energy distributed on the microgrid, and the black start and grid forming functionality. Now, let's move on the introduction from EDF SEI. Etienne, I let you the presentation.
Yeah, thank you very much, Giovanni. So, yeah, as Giovanni just said, SEIN Island is what we call a non-interconnected zone, so there is no power cable between the mainland and the Île-de-Sein island. It is something like 5 miles far from the Brittany coast. As I said in introduction, so EDF Système Énergétique Insulaire, or EDF SEI, is responsible on that territory for the electrical system. One very important point: the electrical system is autonomous. Okay, so the reliability of the different equipment is one of the very key issues for the operation up and time of the different equipment. Some key figures about the electrical system. So the average power is around 160 kilowatts upon the year. Maximum power 450 kilowatt, and minimum power 50 kilowatts. This conception depends very much on the season of the year, if it's a day during the week or during the weekend. So yeah, a consumption that varies very much upon the year. And to have an idea of the energy consumed per year, so it's in 2016 it was 1.5 gigawatt hours. Okay, so until last year, until 2016, electricity was generated solely by gensets, and considering this situation, we have very ambitious objectives in terms of energy transition. These objectives were fixed in 2016 by what we call la programmation pluriannuelle de l'énergie, so which is a law. So it's the law that fixes the objectives in terms of energy transition, and the aim is to reach 50% of renewables in 2023 and 100% in 2030. So yeah. From 2016 to 2023, we must move from 100% fuel to 50% fuel, 50% of renewables, and up to 100% renewables in 2030. So different actions have been put in place to try to reach these goals. So what did we do? So it's EDF and of course all the partners, so the local authorities, energy producers, manufacturers such as Socomec and so on. So first point, of course, reduction of the energy consumption. So this point started 10 years ago. Different actions have been conducted. So the isolation of buildings, distribution of efficient lighting, and so on. In 2017, renewables were installed on the island. We're going to see that just after, but we are, so 90 kilowatt of PV were installed in 2017, and to integrate this renewable generation while maintaining, of course, quality of supply and safety of the grid. A dedicated new control system was developed and put in place. So in 2017, and coupled, of course, with a storage system that we're going to talk about. Also this summer, so this storage system was developed by Socomec.
Okay, thank you, Etienne. So, like you said, in order to develop the energy mix, the idea is to progressively integrate photovoltaic renewable energy while ensuring the grid stability. This grid stability is the major issue with intermittent renewable energy. But it can be solved by adding, like we did for SEIN Island project, energy storage solution, which allow the maximization of renewable energy self-consumption, the microgrid stability, and also the microgrid resilience. In the first step of this project, like you said, Etienne, 90 kilowatt peak of PV were installed and combined with an energy storage about 200 kVA and 185 kilowatt hour. The sizing of the energy storage solution was based on the fact that in some new steps coming in the future years, the total planned PV production could reach 150 kilowatt peak. In this first step of this project, even if the SUNSYS PCS are able to manage alone the black start and the grid forming functionality, it has been decided to let the control of the microgrid to the genset, when these ones are in parallel with the energy storage system. In the started situation, genset supply the microgrid as a master voltage generator, taking care about the voltage and frequency regulation. This is a real specific application for St. Island project. In most of our applications, the energy storage is the master of the microgrid, and the genset are only present as a reserve of energy in case of need. The energy storage system of Socomec has two ways of managing the islanding. The first one is the scheduled islanding, when we receive from the DSO energy management system or from the local supervisor in order to disconnect the system from the grid or from the genset. The second one is the unforeseen islanding, and this unforeseen islanding is mainly used in case of grid failure or genset failure. Now, I'm going to show you the operation of those two modes starting from the scheduling islanding. From the initial state, when the local renewable generation is significant, the energy management software, which has been designed in this precise project by EDF Store and Forecast, can make the decision to start the storage system for two reasons. The first one, to ensure the microgrid voltage and frequency stability in case of instantaneous PV deviation, by making the storage work as a self-generator in parallel with the genset. So in this case, the energy storage system will just follow some P and Q set point coming from the energy management system. The second situation is when the local production is higher than the local consumption. The storage system is started and the genset can be stopped in order to make fuel saving. In this case, the energy storage system will ensure the grid forming and the responsibility of the frequency and voltage quality and stability. When the energy storage startup is requested by the EMS asks for the power ramp of the PCS, thus going a ramp down of the genset power in order to erase completely the current flow on the genset circuit breaker. The energy storage system in this situation is in discharging mode to supply the load. Once the current and the power at the genset level are close to zero, the genset circuit breaker is opened by the energy management system without any disturbance on the load. It means that the load cannot see any perturbation. After the circuit breaker opening, the energy storage system switches automatically from the slave voltage generator mode to the master voltage generator mode. In this situation, the energy storage system ensures autonomously the balance between the local production and consumption, while the state of charge and the power of the PCS are within the operating range. Otherwise, the energy storage system is able to perform PV production regulation acting on the PV inverter through the PF function. It means that in this kind of situation, the energy storage system is able also to ensure the full regulation of the renewable productions. The power sharing between the PCS in this situation is ensured by the hypergroup algorithm. It means that our system is able to ensure the power balance between each unit without any communication link, just by reading the status of the frequency and the bus bar. It's a real robustness solution in order to ensure a long-term islanding. Then, when the EMS forecast or detect a lack of PV production or a low battery state of charge to supply the load, it can ask for the genset reconnection. From this situation, the genset is started, and once the nominal speed and voltage are reached, the EMS asks for the synchronization sequence either done by the genset or by the PCS. The target of this sequence is to ensure the perfect alignment between genset and energy storage voltage, frequencies, and phases. When these three parameters are completely aligned, the controller gives the authorization to close the to close the circuit breaker of the genset. And then the microgrid is again in parallel between the genset and the energy storage. At this moment, the energy storage system switched back from master generator to slave generator, and the genset recovered the master voltage generator mode. The second possibility in terms of islanding operation is the unforeseen islanding. For instance, it could appear on the SEIN island project. This can happen typically because of a genset failure. In case of genset failure, clearly, what's happened? There is a total blackout on the microgrid, and then the EMS detects this blackout and sends to the energy storage system a start order authorization. Once it's done, the energy storage will take care of the supply, of the power supply of the entire microgrid as long as the genset is faulty, assuming that there is enough local PV production and the battery state of charge is high enough in order to perform this functionality. The beginning of the sequence is the black start. The ESS start and then create, I would say, like a ramp up, a soft ramp up of the voltage in order to be able to synchronize all the PCS each other. And the second reason is also to be able to avoid any in-range current on the microgrid, whatever the type of the load. In fact, in our mechanism, in our system, we have two black start modes. The first one is dedicated for standard load, where there is no, I would say, criticity and critical point concerning in-range current. And the second one is for motor load. Motor load or either low voltage, medium voltage transformer, which can create this kind of situation of in-range current. For the first mode, for standard load, the circuit breaker of the energy storage system is closed only when the voltage reaches the nominal voltage. For the second situation, for motor load, we are able to close the circuit breaker when the voltage between each PCS reaches 80 volts. In this case, we close the circuit breaker and we increase progressively, step by step, the voltage in order to reach progressively the nominal voltage. This solution allows to avoid any in-range current on the installation. At this moment, the energy storage system ensures automatically the balance between the local production and the consumption, while the state of charge and the power of the PCS are within the operating range. Otherwise, the energy storage system is able to perform PV production regulation acting on the PV inverter PF function. This functionality allows the extension of the islanding duration. The power sharing between the PCS is ensured by the hypergroup algorithm without any communication link for robustness. When the genset fault is corrected, the EMS can ask for the genset reconnection in case it forecasts or detects a lack of PV production and a low battery state of charge to supply the load. From this situation, the genset is started. Once the nominal speed and voltage are reached, the EMS can ask for the synchronization sequence either from the genset or from the PCS. The target of this sequence is, one more time, to ensure the perfect alignment between the three parameters, which are voltage, frequency, and phases. Once it's done, once these three parameters are completely aligned, the controller gives the authorization to close the circuit breaker. This procedure is done without, one more time, any disturbance for the load. These tests were done during the islanding process to check the value in comparison to the standard EN 50160 requirement. As you can see on the table shown on the right corner, bottom corner, the values are far better than the maximum acceptable value. This solution really ensures the microgrid stability. Now, let's have a look on the main technical challenge of this kind of project. The first one, like we said previously, is clearly to ensure the quality of the distributed energy and to be compliant with the standard, European standard EN 50160. The second one is clearly to ensure the balance between the demand and the response of the microgrid by taking in consideration the power capacity of the PCS, the energy storage inside the battery, but also the possibility to ensure the control of the PV production through the PEF function. The third point is to keep the electrical protection plan. Clearly, in comparison with what would be the short circuit capacity of a real grid, in this case, when we switch from the genset to the PCS or from the PCS to the genset, we have to ensure that all the protection distributed on the microgrid are completely, are correctly tuned according to the power short circuit capacity. It has been validated, this part, by EDF R&D during the Nice Grid project. And the last is to ensure the power supply availability and quality, but logically with power conversion, it's, I would say, a standard features. Now I will let Etienne to make his own analysis and feedback from this project, SEIN Island project.
Yeah, thank you very much, Giovanni. So yeah, I would like to share with you the first return of experience we had regarding the energy storage system from Socomec. So the system was commissioned on site on Île-de-Saint in May 2017. I just want to underline the fact that the contract between EDF, SEIN, and Socomec was signed in February 2017. So in less than 5 months between the signed contract and the commissioning of the system on site. So we were very happy and impressed with the Socomec reactivity. I'm continuing on the feedback. So the photovoltaic plant 90 kilowatt was commissioned in August 2017. So we were able to start really interesting highlanding from August. So when the PV was installed. First of all, I would like to say that the Socomec energy storage system fully meets the technical requirements that were specified. So, as example, of course, power, energy. Very interesting point. The Socomec and together with Store and Forecast, EDF Store and Forecast, did a great job regarding the interface between the ESS and the EMS, which is of course very critical to get an efficient power electrical system. Special good point also regarding the availability of the energy storage system. Once again, Île-de-Saint is an autonomous electrical system, so reliability and availability of the different equipment is really a key issue regarding the operation of the system, and so during the 6 months of operation, the availability of the Socomec ESS was really high, and so as I said, once PV was installed, we were able to start islanding periods. So islanding, and we completely switch off the gensets, and we operate the electrical system with the Socomec ESS and the PV plant, and we've been already able to run the electrical system that way for several dozens of hours, and we didn't see any problem. So we are really confident on the next steps, and yeah, we will be happy to install more PV and see how it's going to behave. But we are very confident. So yeah, maybe Giovanni, I let you the final word.
Okay, thanks a lot, Etienne, for your feedback. So we reached the end of the presentation, and now we can switch on some questions if somebody of you have some question to address to Etienne, Elodie, or me.
Thank you, Giovanni. Thank you all for your presentations. Etienne, I'd like to just ask you a question, actually. Obviously, you're talking, it's a relatively new setup, but you're feeling confident about how it's been operating so far. How do you think EDF might adopt this kind of technology in its wider network?
Well, the first step, so as I said, EDF SEI is responsible for the operation of islands. So the programmation pluriannuelle de l'énergie I talked about fixes very ambitious objectives in these territories. So moving from nearly 100% fuel to 50% renewables in 2023, and so yeah, definitely the kind of energy storage solutions we talked about today and proposed by Socomec is going really to help us to reach these objectives, and we intend and we plan to reuse this kind of solution, and the feedbacks we got from Ile-de-Saint to reuse it and apply it to other microgrids.
Giovanni, if I could bring you in, obviously, the Ile-de-Saint is an autonomous network, so it's a particular type of application. Are you expecting that to be the classic use case for this technology, or what other commercial applications could there be?
Clearly, we can say that it will become more and more often a typical application. This kind of application can be seen in microgrid for isolated sites like villages, industries, or military operation sites. We can already see this kind of application in Africa, South America, or South Asia. The second, I would say, orientation, it's also for commercial and industrial building. More and more, islanding is becoming, I would say, a basic functionality and capability to secure power supply and to ensure the backup of the critical application and allow services and production continuity. So it's sure that we will see more and more of this kind of application, the development of this application all around the world. And generally, it's done like it has been done in SEIN by EDF SEI. It's a progressive approach, starting from the integration of the PV in order to reduce, I would say, globally the OPEX of the installation to make fuel saving. With a moderate capex, it means that, for instance, isolated industrial site wants to avoid to invest too much at the beginning the main issue is the fact that you have to maintain the ratio between the PV production and the genset production in order to ensure the stability of the microgrid. And then they switch on the second step of the evolution and the mix energetic of their installation. So they want to increase PV production to continue the fuel saving. And the last step is to try to switch completely from a full renewable production to have to be completely autonomous and to have only green energy on the site. So clearly, it's a trend that we are seeing more and more for isolated microgrid.
Thank you. Etienne, from a utility perspective, what kind of commitment does the utility need to give to a project like this in terms of manpower, internal resource?
Well, really, what the kind of commitment we need from companies such as Socomec is the reliability and the availability of the system, because we cannot afford yet to operate the system without being able to fully count on the energy storage system, which is as we saw during the presentation, really a key equipment, a key component of the electrical system during the islanding steps. Really, the storage system is the master of the electrical system. So we really do need to count on this equipment. So yeah, the type of commitment we need to get from companies such as Socomec is the availability of the system, and of course some warranties regarding the aging of the storage system. But so of course they are related to the way the utility, so EDF is going to use the storage system. But yeah, this is the kind of commitment we need.
What kind of interest are you seeing from other utilities in this project? And will you be sharing any learnings?
Yeah, well, definitely. I think through this project, yeah, we were. I think the important point and the interesting point that we showed that yeah, within a couple of months we were able to really transform and finally change the way of operating the microgrid of SEIN Island. Yeah, by moving from 100% fuel generation to the setup of an energy management system, a storage system, and we keep. But yeah, we're going to use less and less this equipment, but we keep the gensets, and so I think it's really kind of a demonstration of the possibility to completely change the electrical system and the way of operating it. So I think this is one of the key outputs of the project, and it can inspire other utilities.
Thank you. Elodie, we're seeing a lot of pilot projects happening in Europe, either funded by the EC or, to try and solve the energy transition dilemmas. From Socomec's perspective, can you reflect on any other projects that you're involved with and the kind of learnings that are coming through for energy storage solutions?
So at the moment, we are involved in the next step of Nice Grid project, which is the Interflex project. Interflex is a European project, and there are several applications in several countries, and in France it is the Nice Smart Valley project. And in this project, we are supplying energy storage for islands, which are the Îles de l'Érins. So there are two islands that are, one of them is linked to the main grid and the other one is linked to the second island. And so it's we have to face some difficulties linked to the fact that all the connections are down under the water. So we have high impedance on the network and on the cables, yes, and that is an issue that we need to solve with our energy storage systems. And the second one is that as there will be storage on both islands, we need to make them work together without any communication system.
Okay.
And we also have some other demonstrators in progress with self-consumption applications.
A final question for all of you. How easy is it to prove the business case of microgrid islanding? Giovanni, perhaps you could start us off. When a client's interested in this, how easy is it for you to say, yes, this will save you money and help you to operate better?
In fact, more and more, we have the capability to use sizing tools available on the market, or like for Socomec, we have our own sizing tool. Considering, I would say, all the financial elements that we have to consider. It means CapEx, OpEx, evolution of the cost of the battery, evolution of the cost of the energy, evolution of the cost of the fuel. And taking in consideration all these different variables, putting in place, I would say, the right sizing of the energy storage and the battery, considering what is clearly and precisely the load curve of the site, what could be the production, more and more taking all these elements in consideration, making, I would say, an accurate study of isolated industrial site, like in the middle of the Africa, in Nigeria, in Mauritania. We are more and more able to make the proof that the customer, the end user, we have a real interesting return on investment in roughly right now we can say in about 7-8 years for a system which can last more than 15 years. So clearly we can see more and more interest, and we know, and it's just an evidence, even if you take in consideration the grid-tied application, that the price of the electrical energy will sure have a new evolution in terms of tariff and cost and so on. So clearly all these different evolution, energy costs increase, the optimization of energy storage cost, with also the optimization of renewable energy cost. If you take in consideration all these different elements and you make a projection on the future, it's quite easy and evident to make the demonstration that we will have, I would say, a significant development and increase of this kind of decentralized energy production. It's just sure.
Etienne, same question to you. Does EDF feel that the business case has been proven? You know, I know it's quite a relatively new project, but what are the thoughts there?
Yeah, well, it's quite difficult today to have a perfectly clear vision on the cost benefits from moving to 100% fuel to a new electrical system with the PV energy storage system, EMS, and so on. But so I think we will be able to get some figures from the operation of the system in probably in 1 year or something like that. But definitely, as Giovanni said, this type of transformation is going to be more and more interesting in terms of environmentally and economically, with the decrease of the PV or renewables generation cost, decrease of the batteries cost. So it's hard to. I cannot give you today figures. Probably we will have a better vision in 1 year, but definitely it's going to be more and more interesting, especially in areas where the cost of bringing fuel is very, very high, which is the case for this kind of islands, or for the in the forest in French Guiana.
Thank you. Well, I think this is one project that we'll certainly be following on Engerati. Thank you, Giovanni. Thank you, Elodie. Thank you, Etienne, for your insights, both in presentations and your answers today. Remember, you can watch many more webinars on Engerati, including Socomec webinars. Thank you for tuning in today, and goodbye.